Hello, welcome to the part 2 discussion on architectural details of 8085 microprocessor. The session is continued through the architecture representation. The very first unit that invokes whenever the supply is given to the microprocessor unit is timing circuit. A continuous clock will be generated based on the further requirements. Fetching and decoding of instructions will be happening with the help of memory operations or input-output operations through I/O devices, which will be done through the address buses, and data will be fetched according to the instruction requirement and will be preserved for analysis purpose through instruction decoder area, which will be further brought to the arithmetic logic unit area. So this is a simple flow that is happening through the complete execution operation. So if we look in detail about each part of this architecture, we could have a simple statement arrangement for each pin represented here. So the discussion could be carried out with the first block as timing and control. What are the things that we find in the architecture in representation after power supply is given? The very first thing we would like to see is the clock arrangement. The range given for 8085 microprocessor clock will be 3 to 5 megahertz. Along with these things, the most prominent name that we will see is reset in. General reset operation, which is other further classified as reset in and reset out, where reset in is used for resetting and setting the program here, and reset out indicates the complete CPU is getting reset. Along with this, we will continue with some more pin operations that we require in any architecture design with respect to 8085 and any other microprocessor. Also we will see the similar names. Ready indicates that the system is ready for the operation. When it is giving, it is write operation. When it is taking, it is read operation. Then M by M IO indicates whether it is operating on memory or IO operations. And most important arrangement we would like to see here is ALE, address latch enable. It exists for only first clock cycle, and the purpose of ALE is a strobe operation given whenever an address is generated to indicate that the generated address is a valid address. Then along with that, it will also have some status indication. This differs from the status register. This is status indication to the connected peripherals. What is our microprocessor performing? Some read operation, some fetching operation, some write operation, or it is in stable state or performing no operation, which we consider it as halt operation. In similar way, we will have many such more other arrangements provision given to the timing and control block of our microprocessor. Similarly saying, whenever we can utilize the buses for direct memory access, the device can make a request to hold the buses of our microprocessor. Then based on some positive or negative interest, we will receive an acknowledgement to perform the direct memory access operations. So the other representations that make some prominence are the registers utilized for our microprocessor. The registers are all classified into general purpose registers, memory registers, and control registers. One such prominent general purpose register is the processor register titled by name accumulator. Definitely one of the information, one of the operand, one of the data is always present in the accumulator whenever the information is given to the ALU. And the prominence of accumulator is, if ALU doesn't has any place to store the data which has been generated the output side, it will be by default giving it to the accumulator. So other such support registers with respect to data and sometimes can also be utilized for addressing operations are B, C, D, E, H, L. Individually they are all of 8-bit size, and together they can be utilized as combinations, as fixed combinations. B is always paired with C only, D is always paired with E only, and H always with L only. In support, we will have this program counter addressing operating registers. Then we will have instruction register, which is of 8-bit size, which analyzes the instruction which is to be executed next. In the same way, we will have another prominent register, control register, 8-bit status register for 8085 microprocessor. Out of this 8 bit arrangement, 5 prominent positions are being indicated with respect to 8085 design. One is CY, carry, parity, auxiliary carry, 0 and sign. The positions of these are very important to be represented. Analyzing the names are quite easier. So position stands mandatory that their positions should be as per the design as indicated in the microprocessor architecture. The further versions apart from 8085 could have the same positions with respect to flag bits, and their enhancements could be more based on the size required for the other version of microprocessor. In continuation, we will see interrupt arrangements. So we can see some names. Trap. Trap is a very good instruction which is going to help the microprocessor to check whether any instruction has been generated after execution of one single instruction. So trap is a non-maskable instruction. Then other instructions come in the same order in a priority: RST 7.5, RST 6.5, RST 5.5. These are all some reset interrupt, restart interrupts. Then a very generalized interrupt provision given for any peripheral to get interacted with the microprocessor is interrupt request pin, I and TR. Another such block in continuation we can see will be the serial IO control block. SID, serial input data, SOD, serial output data. And similar names what we can see with respect to the block. If we club all these blocks in a box and we consider it as an IC, we can see the pin representation of 8085, which is of size 40 pin dual inline package. And however, all the provisions we see in arrow marks in the architecture, all those come in the places of these pins. So we can see 40th pin will be holding the supply arrangement VCC 5 volts, then ground arrangement will be for pin number 20. Then if we have a look over the left side of this pin diagram, we can see all those lines in the architecture that were mapped outside, we will see them as the pins here. In continuation with the data lines, along with the completed data lines from D0 to D7, still we require some representation for address lines. The answer is given here. The remaining address lines and remaining pins in operation will be represented in this part. So that was an overview of pin diagram and architectural details of 8085 microprocessor. So we will end up the session for this here, and we will further go to learn about the programming model of 8085 microprocessor. Thank you.